Hey everyone, this is Mr. Spiels. I'm going to be helping you out with higher order derivatives today, and hopefully this video is going to be pretty short. These are pretty basic concept. Just going to do a couple examples with you, and then hopefully you'll have it. So talking about higher order derivatives, let's start with some of the basic definitions here. Let's start with an f of x. Okay, we all know f of x, or a lot of times we call it in physics or calculus problems, can be used as our position function. All right, there's no derivatives or anything going on here. It's just like it's considered your original function. Your f of x is your original function. Or again, in our case, in real world problems that we've done, we've used it as our position function, s of t, as a function of time. Okay, so that's what we know about. If we take the derivative of this, we get to something called f prime of x, and we use this little prime symbol or this little apostrophe to delineate that we're taking the derivative. We've also written it as dy dx. All right, these are the same thing. They both mean derivative. That's been used in our case for velocity. Basically, when we take the derivative of the position function, that gives us velocity. We've used it for rate of change, formula for the equation of the tangent line. These are all things that we've used the derivative for. Okay, so let's move on a little bit and talk about something that we haven't talked about yet, and that's higher order derivatives. So you can take, sometimes I call it f double prime, or the second derivative of the original function. So you have your original function, f prime is the first derivative, f double prime is the second derivative, and for physics and calculus applications, that can be considered your acceleration function when you take the second derivative. Okay, so notice that the first is the velocity, the second is the acceleration. You can work your way down and keep going as many times as you want. So there's the third derivative, okay, f triple prime, or the third derivative. You just have to make sure you mark the 2's and the 3's here in the exponents. You can go to the fourth derivative, so on and so forth. So this is f of n. You can take the derivative as many times as you want, as long as it doesn't, once it zeroes out, you can't go any further. Okay, so those are called higher order derivatives, just continuing to take the derivative over and over again. Okay, so how is this used? What do some examples look like? Let's start with a basic example. So we have a polynomial here, 5x to the third minus 3x squared plus x minus 1. If we take the first derivative, we can use a bunch of power rules here. This is something that we've done the last couple class periods. If I use my power rule here, I'd bring the 3 out front, multiply the 5 and the 3, it'd be 15x. Now I need to subtract 1 to the second. Okay, minus 6x, subtract 1 to the first. Plus, now this is the x would go away and just leave me with 1. This 1 would completely zero out, so I have nothing at the end of my first derivative, or nothing in addition to this positive 1 here. Okay, now this is taking the second derivative. So at this point, you're really just covering up this top part and considering this your starting point and taking the derivative one more time. Okay, so this would be 30x if I take the power rule. Remember, I bring the 2 out front, multiply by 15, minus, this is a 1, right? So 6 times 1 is 6. The x goes away now because x to the 0 is just 1. And also the 1 would go away, so it's just 30x minus 6. Okay, so let's go and take the third derivative. Again, we cover everything else up and consider this our starting point and just take the derivative from there. In this case, I would just be 30 and I wouldn't have anything else, right? And obviously if I were to go one more step, it would be 0, right? So if I had f to the fourth of x, the fourth derivative, this would just zero out. So this is an example of taking higher order derivatives, taking derivatives multiple times. Okay, let's try one with trig. To do this, obviously you might want to pause the video and kind of set up this chart on your own. But we're starting with cosine, and we want to take the derivatives all the way through the fourth one. and then we're going to do sine and take the derivatives all the way through the fourth one, and see how that turns out. One thing that you may have learned in your classes, if your teachers set it up this way, is just making a ladder. So sine x is maybe like a starting point. Derivative of sine x is cosine x. Okay. Then if you were to go down the ladder, derivative of cosine x is negative sine x. And go down the ladder one more rung, derivative of negative sine x is negative cosine x. And then if you're at negative cosine x, to take the derivative, you'd start back up at the top again. So it's just working your way down the ladder, and then when you get to the bottom, you go back up to the top again. So if this may look familiar, may not, depending on how you saw this in class, but we can use this in our problems up here. Okay, so sine, cosine, negative cosine. So let's work with the cosine function first. First derivative, sorry, that's not a negative sign, hopefully. So first derivative of cosine is negative sine. I'm just going right down the ladder. Okay, now if I were to take the second derivative, I'd start at negative sine and go one down the ladder, so it'd be negative cosine. Okay, and if I were to take the third derivative, I would start with negative cosine and say, okay, what's the derivative of that? Well, negative cosine looks like I could start at the top of the ladder again, would be positive sine x. And then one more time, the fourth derivative, if I were to take the derivative of sine x, I would just go one rung down the ladder, and it would be cosine x. Looks like after the fourth one, we end up right back where we started. Okay, which makes sense. Let's try sine. So we'll start with sine. We want to take the first derivative. So here's sine. I go one down. It'd be cosine. Okay, the second derivative. Okay, so that means this is my starting point now. So I'm starting at cosine, and derivative of that would be negative sine x. Okay, I'm going to my third derivative. I'm starting with negative sine, and I'm going to my derivative, which would be negative cosine x. And then finally, one last time, my fourth derivative would be, again, I would cover all this up, consider negative cosine to be my starting point. The derivative of that would be, going back to the top of the ladder here, would be sine x. And again, we finish right back where we started. Okay? All right, last example, and I would encourage you guys to just kind of maybe write this example down to start with, and maybe pause the video and just try it on your own and see if we come up with the same answer. But the directions are, which level derivative will render the following equal to 0? So how many derivatives do you have to take to make this equal to 0? Try it on your own, and then obviously check your answer with mine, and I'll try to give you a little shortcut at the end as well. Okay, so my first derivative would come out to 12x squared minus 4x plus 5. Okay, right, I'm just using the power rule right here. My 7 goes away. The second derivative, or f double prime, would just be taking the derivative of this now. So again, the power rule, 24x minus 4. Okay, constant goes away. The third derivative, let's keep going because the question said we want to go to 0. So the third derivative, this would just be 24. Third derivative. And it looks like the fourth derivative is finally going to get us to 0. Okay, so it looks like there it is, the fourth derivative. Another kind of easier, quick way to look at this is your highest exponent is 3. So in order to get to 0, you're going to have to go 3 levels down, so 2, 1, and then my exponent goes away, and then you add 1 to get to 0. Okay, so you drill down, basically you'd add 1 to that exponent to get down to your 0 derivative. Okay, hopefully these notes helped. Again, higher level derivatives or higher order derivatives are just taking the derivative multiple times up to the one that it's asking you for.